using the same dataset that I used before, collected from the students. So what I have is I have different genders and I have their different political views, and I also have agreement or disagreement with a statement about whether men or women should be about whether married women should their places in the home. So that's quite a conservative statement. So what I can look at is there a difference in opinion between the two different genders? Are men or women more conservative in their social views? So these type of questions. First question I can ask is, are men or women more conservative? So that relates to the agreement or disagreement with that statement. So I want to look at the relationship between the gender column and the agreement column. The other thing is I can look at, is there a difference in political preferences between the different genders? So I can look at gender and their relation to politics. Now, because these analyses have two columns that you're comparing to each other, you're counting how many people support a particular party that are male, how many support them that are female, how many support them that are non-binary. This is called a cross-tabulation because you have rows and columns. So in this case, the rows are going to be gender and the columns are going to be agree or disagree, or the political party. So to do that, you want to go to descriptive statistics and cross-tabulations. So I want to put in rows, going to be gender, and the first one I'm going to do is the political party, so that's going to be the columns. How would you describe your political things? You can display bar charts at the same time to look at these comparisons, but I'm not going to do that at this point. I'm just going to go OK to get the cross-tabulation. Oops. One other thing that's useful actually is to do percentages by row, because then I can look at each of the different rows and see if the percentage changes between the different genders of support. So that is a more convenient way than having absolute numbers to be able to compare, is there a difference in between the rows in their preferences. Because if you've got very different numbers in each of the rows in total, which I have here because there were a lot more women than there are men in the survey, then it's difficult to see on its own whether the proportions have changed. So if I press continue and I press OK, now I get this summarized cross-tabulation. So they're called this is a cross-tabulation. They can also be called contingency tables. So here you have female, 15 are conservative, 5 are green, so it's 8.7% conservative. In male, there's 14.3% conservative. So this would suggest that there's twice as likely to be conservative if you're male compared to female. Greens, there are no males. Labour, 61% compared to 64%. That's not a very significant difference. Liberal Democrat, you're twice as likely to be a Liberal Democrat if you're female compared to male, and the others are roughly about the same. Non-binary, you can't really take any lessons from this because there's only a single individual, which in this case is a Labour supporter, and they prefer not to say is also a Labour supporter. But that data set is too small for you to take any messages. If I go back and do descriptive statistics and cross-tabulations again, so now we're going to do agree or disagree with the statement. So I'll press OK. So in this case, agreeing with the statement is a conservative value. Some people put agree and disagree, so they've managed to tick both of the boxes. They're sitting on the fence. So you have 18 agree, 153 disagree. So 10% agree, 89% disagree. Whereas in males it's 24.5%. This means they're roughly 2.5 times more likely to agree with the statement and have a conservative social view compared to women.